you know how much I am connected to you people. Thanks for inviting me for this session. And I'm not sure that how this session will go because this is the first time I'm doing this session. So I have planned something. So what, as for my discussion with Dr. Ranjan, what I have planned is I'm just imagining one anesthesia machine or workstation which is been in front of the candidate, and then how the question will flow. And we'll be trying to have more on the kind of questions which is generally asked on the to the participant. But what I will like to point out here before going into the session is generally the examiners, they don't spend much time on the on the anesthesia workstation question. Generally, it will typically take around 5 to 10 minutes maximum. But what makes and breaks about this session for a candidate is there are some basic questions are there. If it is not answered properly, it gets a very negative impression on the examiner. Though the candidate will be knowing about what it is, but if you are not able to answer those things, maybe a little difficult situation you are. So what I have planned is I will try to cover as far as possible on the machine thing. Definitely all the questions will not be asked. Generally out of this maybe around 20-25 questions we have planned. Out of that anybody can get over 2 to 3 questions. So just I want all the PG, exam going PG to have the question area focused, and then later they can also refine on their own workout. So without going much and rest of the things we'll leave it for the last question and answer session. So we'll start from the first thing. So generally you will be having one or two, even two different type of machine, anesthesia machine, and you will be asked to identify this. And everybody knows that once you are asked, or the examiner may ask you that what you call this device. So there is actually a little bit of catch. We are all, if it is a Boyle's machine, we all will be calling it as a Boyle's machine. But if you are just answering it as a Boyle's machine, then they may ask, is it the generic name or it is a specific name for the machine? So if you are asked about the generic name, then more commonly used term for this kind of device is known as continuous flow anesthesia machine. It is dates back to very few centuries, very few decades. Then you have to know what is intermittent flow anesthesia machine. I'm not going to detail of that. So you can say that this is continuous flow anesthesia machine. At the same time, you also can have a machine. Generally, in our exam also we had two. We had a basic Boyle's as a generic one, and we also have a anesthesia workstation. So there the examiner may ask you, what is this? Then that time you may call it as an anesthesia workstation. If you are telling that this is continuous flow anesthesia machine or a Boyle's machine, and other one you are calling it as a anesthesia workstation, then the question can be asked that what is the difference between these two? So, there to answer it in a simple way, anesthesia continuous flow anesthesia machine or the Boyle's machine, or sometimes it is also called as an anesthesia delivery unit. Again, that term is a little confusing because Viva has used it for some of their products. So anesthesia delivery unit. So anesthesia delivery unit or continuous flow anesthesia machine is a machine to precisely deliver anesthetic agent only. So if the machine is only serving that purpose, we call it as an anesthesia machine or a continuous flow anesthesia machine. But once you add more functionality to that, for example, you have monitoring into that, then you have, of course, the automated ventilation part can be a part of machine or can be a part of workstation. So workstation idea is generally whatever you need to conduct your anesthesia, more and more components are incorporated into the machine. That is how the anesthesia machine become anesthesia workstation. So now more or less, even the drawers where you keep your airway devices or you keep your endotracheal tube are also considered as a design component of anesthesia. So that is what, and then further we can go into detail of that, but I'm not going into that. So now, if you have answered that, the next question will come that suppose there is a basic Boyle's machine. I'm using the Boyle's machine term because people are more comfortable hearing that. So I'm saying that if there is a basic Boyle's machine or some kind of boil machine which can be opened and kept it for you, then they may ask, the next question is identify the component. Even if it is a workstation, it will be asked to you that you identify the component, or the examiner may point out certain component and say that you just, if you are a last candidate and the exam is going to get over, they may ask you to identify this component. What is this component? So I would ask, component wise also each and every component, but I will ask the exam batch that you should get used to what is the standard term described for that particular thing. Suppose where you are connecting your, just to give an example, where you are connecting your circuit, that is known as common gas outlet. Suppose the examiner points you that, and what is this? Then you should immediately say that this is a common gas outlet. The question will end there. Suppose there is something called, we'll again come to that, ACGO. What is ACGO? It will be written that it is ACGO. What is ACGO? So like that, the component, any component can be pointed at you, and it will be asked. So since this session is on anesthesia machine, so we will only restrict ourselves up to the common gas outlet, and that side will not go into the cylinder and pipeline and all. We'll only restrict to the machine. So at that level, you're supposed to identify any component which is pointed to you, or you can also be, you will be asked maybe sometime, if you are good, you have done something good in your clinic, and the examiner is a little more interested in anesthesia workstation or machine, they may ask you to trace the flow of gas. So in that, that's a complete way of knowing the machine. So where then they will remove the top of the boils machine, and they'll ask how the gases are entering. So that is the next case, next question asked to you. So from the starting from the cylinder point, then cylinder point, that is here is a EF assembly, then you have a pressure regulator, then gradually you have to go. Then you have to trace the oxygen pathway as well as nitrous oxide pathway. Then you have to go up to the flow meter. Then you have to go to the vaporizer. Then from the vaporizer, you have the back pressure check valve, and then you can go to the common gas outlet. Then in that itself, you can also have a line for which is going. Actually, the older boils machine, you have once the oxygen comes, the pipe will go to 5 different places. But right now, people may not be asking you, so I'm not going to confuse you with that. But there is one more line which generally goes to the oxygen flush system or emergency oxygen flush system. That also will come to it in a little while. So I'm not discussing this. So what I'm trying to say here is, once the examiner asks you to trace the gases, means you have to just start from the pipeline or the cylinder input point and then go up to the common gas outlet, but for both oxygen as well as nitrous oxide. And in the meantime, whatever comes in the way, you have to identify that component. What I will request you is that basic, this thing can be done in your own hospital. Whenever you are preparing for your practical exam, spend some 10-15 minutes or 20 minutes to identify such component in your hospital. So that is the second question. Now the third question can come there is, this anesthesia machine can be divided into different pressure zones. So that is one. So pure pneumatic machines are classically described as 3 zones. That is high pressure zone, intermediate pressure zone, and low pressure zone. When you say that the high pressure zone, intermediate pressure zone, and low pressure zone, then the next question can come to is, what are the points where up to which point you say this is a high pressure zone, up to which pressure you will call it as a intermediate pressure zone, and which is up to from where you call it as a low pressure zone. That is the second question. And another question can come is, what are the pressure range in this zone? High pressure zone, intermediate pressure zone, and low pressure zone. So classically, the high pressure zone is between 2000 to 55 or 60 psi. 62, you come to second stage regulator is there or not there. Up to the flow meter, it is that working pressure, and then beyond flow meter is a low pressure system. Now again, the modern anesthesia workstation, this high pressure, intermediate pressure, and low pressure zones are little blurred, where you have multiple pressure regulator and different component working at different pressure. But it is a classic question that how you divide your machine. So before the first stage pressure regulator, it is the high pressure system. First stage pressure regulator to the flow meter is the intermediate pressure zone, and then beyond the flow meter you have a low pressure system. So that is the thing can be asked to you, and then you should be able to tell from where to where, what point it is called this zone, and then what is the working pressure. Generalize it. It is not fixed. It varies from machine to machine. You can talk about that. Now let us start with each component. So as I'm not coming, as I said that I will not be discussing about cylinder, will not be able to discuss about the pipeline. So let us start from the yoke assembly. So yoke assembly, you should know what is the purpose of the yoke assembly. You should know that there is a unidirectional valve, and then what are the steel used there, the pin index, that also is a part of machine. Though it is meant for cylinder, it is part of the machine. So somebody can ask you yoke assembly, and there identify the pin index system, and then all these things can be asked. So you start from the yoke assembly. So if you are connecting a cylinder, that means directly you are connecting a 2000 psi pressure. I'm talking about oxygen line, and directly it is about a 2000. So after yoke assembly, you generally will have one. This is I'm talking about a classic Boyle's machine. See, we will talk about classic. Then we may cover the anesthesia workstation and modern machine. So in that also we'll find out what are the difference we have in those machines. Can be asked, rarely asked, but can be asked. We'll discuss that. So yoke assembly is there. Now it comes to pressure regulator. Now pressure regulator again can be asked in that way. So what is the principle of working of a pressure regulator? If you are saying that there is a pressure regulator, so it will be asked to you that what is that. You all of you should know that it is various area versus the pressure. Smaller area, large pressure, and large area, small pressure. Q1 V1 equal to P2 V2. So that principle you should know. You should tell about that. I will be skipping theoretical details to keep the discussion more practical in nature. So that should be done. Then second question we asked that these pressure regulators are gas specific. Yes, the older one was gas specific. You have a separate pressure regulator for oxygen, separate pressure regulator for nitrous oxide. Whatever you are using air, you have a separate pressure regulator. So because those regulators are calibrated for those gases, because oxygen, you know that it is highest nitrous oxide in lower range of pressure, not lower, but it is not half of the less than half of the oxygen pressure. So the older pressure regulators are gas specific. You have something called universal pressure regulator. So the make is same for oxygen as well as nitrous oxide, but again the calibration is different for oxygen. So simply you cannot take one pressure regulator and attach to the other one. Of course, you need to little bit. So now presently all the machines are using not about the classic Boyles, the later workstation and little modern anesthesia machines are using universal pressure regulator. That is the design is same for oxygen as well as nitrous oxide, but it will be calibrated to that. So oxygen pressure regulator, you can be asked like that. Then you can also be asked that what are the type of oxygen pressure regulator you know. So you can there is no classic division, but generally in the older machine you something called not older machine, newer machine, first stage regulator and second stage regulator. So what is first stage regulator? What is second stage regulator? So first stage regulator is a regulator which brings down the high pressure to the intermediate pressure. So that is 2000 psi to 60 psi. If you have a pipeline supply already, that is reduced and it is coming to 60 psi. 60 to 55 to 60 psi. Then many machines for different components, they put a different pressure regulator. That is called a second stage pressure regulator. I'll give you an example. Suppose you have let us say that you have a link 25 system. So link 25 system, to feed to that flow meter, you need a particular pressure for oxygen and nitrous oxide. So for that, you have one more level of pressure regulator, which will supply to that 25 or 30 psi, what requirement for that particular component. So whenever it is for the internal working for that particular make of anesthesia machine, you have one more pressure regulator that is called second stage regulator, and the second stage regulators can be multiple also. For different line, you can have more second stage pressure regulators. So that is to reduce from 60 psi to another level of psi, that is 25, 30, 20. Even there are something called 40 psi. I am not going into detail, but second stage regulators also can be there. Then another one type of classification is, so again, that is the older one, that is called master and slave regulator, where one regulator will be regulating the other regulator, working of the other regulator. That is why it is called as master and slave regulator. A classic example is nitrous oxide regulator. Nitrous oxide regulator is classically called, nitrous oxide regulators are classically called master and slave regulator. Their master is the oxygen and the slave is the nitrous oxide. That means unless and until that regulator is fed with a particular pressure of oxygen, the nitrous oxide will not be flowing through. This is a part of safety design. And when we will be discussing the safety component of the machine, again, we'll come back to that briefly. So you can also have this kind of differentiation, master and slave regulator. Now, so that is about pressure regulator. Anybody wants to have some question on that, you can take it later. Now, next thing will be there. Even that component will be before the pressure regulator. But just for this thing, I put it after the pressure regulator. But that is called pressure gauge. What is the role of a pressure gauge? Pressure gauge will measure the line pressure. Line pressure in the sense, when we call line pressure, that is the pressure which is supplied. We are not talking about line pressure of the entire hospital gas supply. We are talking about the supply which is coming to the anesthesia machine. So you will have all the machines what we are working with. I will have two for each gas. That is, one is for cylinder pressure, one is for pipeline pressure. So again, there the unit may be vary. So generally we talk about PSI. You will be seeing many pressure gauge which built into your workstation. It will be in kPa. So some question can be asked about the unit conversion. Generally, it will between the kPa, atmospheric pressure, and PSI. So that is three confusing units. So please get clear about those units. So conversion rate and all. Because of this kind of arrangement in our machine, we have a gauge which shows, some machine will show in PSI, some machine it will be showing in kPa. So that is the other thing. Now all the modern machines are coming in kPa. Next question can be asked in the pressure gauge is, what is the working principle? So previously pure pneumatic pressure gauge, where on most common one is used as a Bourdon tube. So working principle of Bourdon tube, that how the tube gets straightened with the increasing pressure and how the indicator moves, that you should know. Then another one type of pressure gauge is called aneroid gauge. There one expandable chamber is there and the pointer is connected to that. More pressure, more the chamber will be expanded and the pointer will move. Generally in India, there is not much of machine using it. It's a dragger design, so it is not used. Then the question can be asked that what are the modern or electronic pressure gauge? Because you all know that electronic pressure gauge is a very common thing, even used in your car. Even the bike has started coming with the electronic pressure gauge, where the tire pressure is showing you in electronic format. So that is being incorporated into workstation. So you should know there is something called electronic pressure monitoring. You know. So next question can be asked is, what is the technology used there, or what is the principle used there? It is simple. Just you can remember one thing, that is piezoresistive transducer. So those are close to a transducer which you use in your arterial line, but these are all meant for high pressure systems. So the principle here used is piezoresistive technology. You can say that, and we'll not go into detail about that, what is piezoresistive, what at all. But in principle, they are similar to your arterial pressure transducer kind thing. So pressure gauge, we'll leave it there. And then, so you can have various pressure monitoring, various point pressure monitoring also. In anesthesia, modern anesthesia workstation, it is not a single point pressure monitoring. The pressures are being monitored at different points to find out the fault or do automated test, everything. So the old machine, you have one pressure gauge, which is at the entry point. but in a new machine, you will have multiple. Maybe one is display, but the other things are monitored for the safety feature and auto check. So that is the pressure gauge point. Now come to the next component, which is in line. We are going to talk about the flow meter. So flow meter is actually not only it's a dual purpose device. It is a flow regulator as well as meter. So you regulate through a valve, and then it will be asked that what kind of valve is used in a classic machine or mechanical machine. It is a needle valve. So as you rotate your knob, the needle will open and then the gas will flow. What gas is flowing is being measured by your flow meter. The glass tube is measuring the flow. The control is in the needle valve, but the flow is being measured by the glass tube. Now, the second question will be asked that how the measurement, what is the principle of this particular measurement? That is, all of you should know that our classic oxygen flow meter uses the constant pressure variable orifice principle. So again, there is other one is there, variable pressure constant orifice. We will not go into detail of that, but the flow meter which we are using generally use a principle that is called constant pressure variable orifice. So that is what you should know. You should immediately say that it is a constant pressure variable orifice flow meter. That means the orifice around the bobbin or the float is varying as the bobbin or float is moving up or down. When it was moving down, the area is less. When it is moving up, area is more. But at one particular point, the pressure above the bobbin or the float and the below the bobbin and the flow are same. So that is why it is called constant pressure variable orifice. And then the second thing will be asked is what is the type of tube? What is the tube is called? That is soap tube, and it is little tapered in the down and it conical shape. It goes up. That is how the pressure is. Sorry, the area around the float or the bobbin is increasing. Then again, you may be asked, nobody asked now, but you can be asked what are the kind of float you know. Then skirted float and ball design and all this. At what point you will record that? If it is a ball, at what point you will record the flow? And if it is a float, top of the float or the bottom of the float, what point you will say that this is the flow of the gas? So that is the question can be asked. That's a very common thing which is asked. Now, again, the question will be asked that can the flow meter, you have a flow meter for oxygen, you have a flow meter for nitrous oxide, air, or older machine carbon dioxide also used to be there. So let us talk about air, oxygen and nitrous oxide. So the next question is, can we use one flow meter for other gases? Like oxygen can be used for nitrous, or nitrous flow meter can be used for oxygen. So the answer is no. Why no? Because you all know that the measurement is again depend on the flow calibration. The flow meter is calibrated for a particular gas, and you know that when the flow is laminar and the flow is turbulent, that depends on the viscosity and density of the gas. So if the viscosity and density changes, the calibration also will change. So gas to gas viscosity and the density changes. That is why we should have a particular calibrated flow meter for a particular gas. You cannot interchange a flow meter. Nitrous cannot be put in the oxygen line, and the oxygen cannot be put in the nitrous line. So that is the second question. So now, what then the question? Second question is, what is that flow meter? You generally will see 2 or 3 gases flow meter in a single point. You will have oxygen, you will have nitrous oxide, you will have air. So what is it called? It is actually called as manifold, because that is more than one gas is connected. So this is all commonly known as manifold of flow meters. So that is the way it can be asked. It may not be asked to you, but you should know that it is also called as manifold. One manifold, we know that it is in the gas plant where we connect multiple cylinders. One manifold you have in your flow meter. The second thing can be asked is, in the manifold design, what is considered? That is a debatable question, but you may be asked that where the oxygen should be. Oxygen should be on the last, but it is not called as first or last. It is always described in terms of upstream or downstream. So many of you would have known that what is upstream and downstream. It is taken from the flow of water. When you are when the water is flowing, here you have to imagine the gas. Gas is flowing, which is in the later point of the gas flow is known as downstream, which is at the first point of the gas flow is known as upstream. For example, the vaporizer is a downstream arrangement from the flow meter. When the gas is flowing, it is flowing to the vaporizer. So vaporizer is downstream, flow meter is upstream. Similarly, when you are talking about the manifold of the flow meter, you know that where the oxygen should be. So commonly, again, it is debatable. To prevent hypoxic mixture, the answer should be the oxygen should be downstream to the nitrous oxide and air. Oxygen is the last tube. But again, there are, if you read detail into that and somebody is very interested, may ask what is the disadvantage of that. We can talk about that. But you remember that oxygen is the downstream of the flow meter. Now, at the flow meter level itself, the other questions can be asked. This is a little advanced question, or if you have a workstation, a modern workstation, which is being asked to you, then you can be asked that, what are the other type of flow control you know? So the next answer is electronic flow control can be there. The gas can be here, as we said that there is a needle valve which is controlling the flow, but the advanced workstation use a electronic flow control where the flow of the gas is precisely controlled by a microcontroller, which is opening a valve as per the requirement. So everything is electronic there. So there is no mechanical component there. But to have you feel of the older machine, some machines give you a knob kind of arrangement where you will know that this is oxygen knob. When you rotate the knob, there is no needle valve opening there. It is just giving an electronic signal by which the electronic flow control valve is opening and the oxygen and the nitrous oxide is being supplied. So there you can have various arrangement, individual flow control, or you can have a total flow control and the percentage of oxygen in that mixture. So you have different company employing different formula. But basic principle is there is no mechanical valve there. There is an electronic valve which is opening and regulating the flow of oxygen and nitrous oxide. So that is for that. Then you have electronics measurement also. So the flow, which here your tube was measuring the calibrated tube was measuring the flow. There the flow will be electronically measured, and you know that various way of like heated wire anemometer. Then you have differential pressure flow sensor. So you have a flow sensor in the line which measures the flow of the particular gas. So here the previous one we have known that mechanically controlled, that is needle valve was controlling. Then we have Thorpe tube or calibrated tube which is measuring the flow. Here you can have electronic control, you can have electronic measurement. There is something called hybrid where the control is mechanical but the measurement is electronic. So that is called hybrid type of flow meter. So we have completed the flow meter. Then one more question can be asked in the flow meter. You will be seeing that many this thing, you will see two parallel flow meter for one particular gas. Oxygen will have two, and you will see the nitrous will have two. So why so? It can be also asked if you have such kind of machine which is there. Why there is two flow meters for one particular gas? Because it is calibrated, the calibration is more, you want to use a lower flow. So you to have a lower calibration tube, that you need a two. That means one tube, one flow meter will be up to 1 liter, and the other flow meter will be in connection in the series. That means the gas flows through the smaller tube first and then they go to the larger tube. That is why it is called a series connection. So the oxygen will first flow through a precision calibrated, that is the where it is calibrated like 10, 20, 30, 25, like that will be calibrated. The full oxygen flow meter will be calibrated up to 1 liter, then it will go to 1, 2, 3, 4, like that it will. So you can that is mostly used for applying your low flow technique. If you don't have such precision calibrated flow meter, you cannot go for a flow of around 300, 400, 500 you want to use, it will not be that accurate. So to have a very accurate measurement and control of your gas flow, you can have two parallel. Though visibly the tubes are parallel, but they are connected in series. So that is about parallel flow meters for a single gas. Now coming to vaporizer, I will just talk about the questions because I don't know. We may not be having time to discuss in what are the type of vaporizer. Vaporizer itself is a session, and many examiners keep separate vaporizer table viva for you. So vaporizer is a totally different thing. But what I should tell you, if it is commonly asked to you, what is the vaporizer? The most common vaporizer, the principle there is a concentration calibrated variable vaporizer. So this term at least you should know. Now, all the tech vaporizer or the drag vapor vaporizer, mechanically operated vaporizer are concentration calibrated variable bypass. So what is the other type? That is measured flow vaporizer. We are not discussing that. Now you should identify, then you should know the principle, what is there, then is it agent specific or not, what is temperature compensation, what are the law used in the vaporizer, then what are the vaporization method, what is flow over, what is bubble proof, what is injection vaporizer. I'm just naming the questions. If you can read, you should read. So it is a different class altogether. Then what is pumping effect, what is pressurizing effect, what are the agent parameters or factors, which is like boiling pressure, latent heat of vaporization, all these things, saturated vapor pressure, all these things may be asked to you. So that is the thing about vaporizer. I will not touch more on the vaporizer. Then it is part of again we'll discuss little late. What is a select a tech mechanism? That also will come late. We will discuss that as a part of safety features in our machine. So once the vaporizer is over, then the next component which is there is something is known as something commonly known as machine outlet check valve. Machine outlet check valve generally have two. It has it acts as pressure relief valve. For some reason, if there is a very high pressure coming back to the machine, it protects the machine by opening the valve. So that is called a pressure relief valve. And in the same component, there is one more component which is called back pressure check valve. So it doesn't allow any pressure from beyond that, from downstream to that point. Coming back to the machine, that is a flow meter. So no pressure will be transmitted to the machine. So that component is commonly known as machine outlet check valve. Most of the machine have dual purpose that incorporate a pressure relief valve, and this valve generally opens at 5 psi. If the pressure in that system is more than 5 psi, and the valve will automatically open, so that it will prevent the damage of the machine. So pressure relief valve is made to prevent the damage to the machine, but back pressure check valve is incorporated, that is working on the lower pressure. When the common working pressure itself, that will be working. That's a unidirectional valve. So that doesn't allow the gas from the circuit to go back to the machine, by which it can change the composition of the gas. So we have two. One is pressure relief valve, that is for preventing the damage of the machine. But back pressure check valve is to prevent or to have the machine working in a particular pressure. Now from that point onwards, you can have a common gas outlet. So what is a common gas outlet? That means that gas which is a common gas outlet, it is known because it is a common for all the gases. It is that oxygen, nitrous oxide, or whatever agent, isopropane we are using, all gases are mixed, and then you have coming to the circuit where you should connect the circuit. Now at that point in the older machine, you can have something, again it can be asked to you that identify that will be some switch kind of thing where you can change from a closed circuit to open circuit. That has to be identified. If you have an older boys machine with you, that design was made where the closed circuit was permanently connected to the machine, and you can switch over from the closed circuit to the open circuit by moving a lever. But because of the safety concern, now most of the machine, they will not have that particular switching lever. It will only have a common gas outlet. You either connect a main circuit or you just remove it to a closed circuit. So that is how it's commonly used now. then you have something called ACGO, that is called auxiliary common outlet, common gas outlet. So that again is a thing where the compact or more integrated workstation where everything is connected to the closed circuit and you are supposed to use the closed circuit. There they name it as a ACGO. So whenever you have a lever that is like olden days closed circuit to open circuit, there just you switch over the lever. That means you just ACGO on or off. There will be a lever where you can, there are many machines provide that. So you should be able to know that what is the common gas outlet, or if there is ACGO written in your machine, what is ACGO. And then you can also have something called auxiliary oxygen flow meter. That is common, that is not connected to any circuit. It is separately taken from the oxygen source, from the pipeline source or from the cylinder source itself to your machine to give a auxiliary source of oxygen. Many machines are now coming with that. So that also you should know. That is a different, that will not, that flow of oxygen doesn't go through any of this circuit. It directly taken from that. Similarly, one more direct oxygen feeding is being done to something called oxygen flush system. So oxygen, what is oxygen flush system? Oxygen flush is always incorporated in machine, and that is again a direct oxygen supply from the oxygen pipeline or cylinder to your common gas outlet. So as I said, the oxygen from the oxygen source can be taken to a auxiliary flow meter, but all the machines will always have an oxygen flush. But there, the oxygen is totally bypassed from the cylinder and fed to the common gas outlet. But what are the, why it is being made like that? So the next question can ask, why should we have an oxygen flush? That is to give you a oxygen when the entire machine fail. All your electronics, electrical, everything has failed, but the pneumatic component is working. So if you just open the oxygen flush, it will, the high pressure oxygen, that is 60 psi oxygen, is being delivered to your common gas outlet. So you should know what is the compressor. If you just turn the and it is pre-loaded. Why it is safety mechanism? You should the oxygen on for long time, because as you know, as we have discussed, that is a high pressure system. So you cannot have that PSI going your oxygen so to going to your patient lung for long time. So that is one thing. Then you should know what is the flow. So it can give some flow between 35 to 70 liters per minute. So that's a very high pressure. So always it should be switched on for very transient period of time, for few seconds only, not more than that. So what is the safety feature incorporated in that? That is the accidental switching on should be prevented, and locking of the oxygen flush should not be there. So that is, as I have told, that is the tracking of the component. We have completed that. Now we will come to a few other components which is not part of your oxygen machine, but it will be asked because it is incorporated into the oxygen, into the anesthesia machine, and but it is a component of an anesthesia workstation. That is one component which you will be always will be asked is anesthesia ventilator. So always your machine will have a ventilator. The first question can be asked is, how these ventilators are, I'm talking about the classic yellow on a bottle kind of design. If that is there in your exam, it will be asked that how this ventilator is different from a ICU ventilator. So this ventilator are dual circuit ventilator. Dual circuit ventilator means the bottle is filled by a different gas and the bellow is filled by a different gas. So since it is an anesthetic agent or anesthetic gas mixture you are going to use here, there you cannot have the driving gas mixing with the anesthetic gas. So that is why it is a dual circuit. The gas inside the bellow is an anesthetic mixture, and the outside the bellow but inside the bottle is a driving gas. But there are few anesthetic who single for example, Drager ventilator. This is only one gas. That is the anesthesia gas mixture. Other one is the electrical force applied to a piston. So there is no mixing of gas. There are, but commonly used one is a dual circuit anesthesia ventilator. Then you should also know that there are certain volume reflector kind of ventilator which is there in flow I and all. It's a very, nobody will ask this question, so we'll not go into that. Other type of anesthesia ventilator. There are 4 types. We'll not discuss. Then the last component should you also should know that what is the AGSS, anesthesia gas scavenging system. What are the types? It can be active, it can be passive. When it is passive, what is the advantage and disadvantage? When it is active, what you need? So you need what are the valves should be there? You should have a canister. It should have two valves, and the opening of the what pressure the in valve should open, at what pressure the out valve should open. All these things should be known. Mostly this is rarely asked, but definitely this question is a very common. What is the AGSS system? So AGSS system, that is anesthesia gas scavenging system, and what are the types, active and passive. So this much if you know, that is sufficient. More you want, you can read. Now come to the second component. I don't know if I'm overshooting the time. Please, the organizer can tell me if I'm overshooting the time. We can
no.
Oh,
Sorry. Go ahead.
Yeah. So now then the second question, which is common to ask, second level of question, that is safety features. So let us talk about different questions which is asked in the safety feature. So first thing is why you need safety features. At what front of your anesthesia practice you want to have a safety feature. So it is actually broadly classified into, not classified, you can enumerate in this way, that the first concern is the machine should have safety feature by which it should prevent the hypoxic mixture. So you are more scared of delivering a hypoxic mixture. So there are series of safety features in your machine which prevents to certain extent, not always, to certain extent, that hypoxic mixture should not be delivered to the patient. So that is one. Second category is that wrong agent should not be given. So that is the second thing. So you are thinking that you are giving isoflurane, but you will be giving sevoflurane. You are thinking that you are giving nitrous oxide, sorry, oxygen, but you will be giving nitrous oxide. So that is also a kind of wrong agent. Suppose you want to give oxygen, but you are giving air. So giving a wrong agent, that is the second point. Hypoxic mixture and wrong agent as the second thing. Then third thing is giving some thing in a excessive manner. You are the precision. That is, you should not be giving. Suppose you want to give 2% sevoflurane, but by mistake you should not be delivering 5%. So those components are also incorporated. That is little advanced component. That is the excessive agent. So we discussed about hypoxic mixture. We discussed about excessive. We discussed about wrong agent being delivered, and then that is something called pressure, because you know that barotrauma is a very serious thing. So you should, because you are taking a high pressure gas mixture into the machine should incorporate your mechanism or safety mechanism where it should prevent pressure buildup in your machine. So that is the fourth category. That is one way of describing safety features. So features for preventing hypoxic mixture, features for preventing wrong agent being delivered, features for preventing excessive agent delivering, features to prevent pressure. So that is one way. Another way of talking about the safety features. Safety features are of two types. One is in the alarm type. It will always tell you that something is gone wrong, and what is gone wrong is being given to you by audio visual alarm. Sometimes it is only audio alarm, sometimes it is audio visual alarm. Most of the common modern machine will have both audio visual alarm. So that is one. Second type is a engineering design which is incorporated, or engineering technique is incorporated in your machine, which is preventing this from happening. So two types. One is alarm, another one is mechanism which has been incorporated. So either you can be asked about what are the alarms present in this machine. So oxygen failure alarms is the most common alarm which is incorporated in all machine. All machine will have an oxygen failure alarm. Other things are there or not there. All the advanced machine will have different level of alarm: high pressure alarm, low pressure alarm, high oxygen pressure, low oxygen pressure. All these things are there. But the most common and the must to a machine is a oxygen failure alarm. Oxygen falls from a particular pressure, then the alarm will be given. And classically, again, if you have older machine, you can be asked that what are the type. You have a mechanical whistle, which is Ritchie's whistle incorporated in the older boys machine, or the electronic alarm. So modern machine uses a electronic alarm. There is a pressure switch incorporated into your anesthesia workstation. When the pressure falls, the switch gets triggered and the alarm comes. So there you can read about what are the type of alarms in your that particular machine. If it's in your institute and you know the machine well, which has been kept there, you can read about that. Now, what are the mechanism which has been incorporated into the system? So that is again a full talk. We will briefly identify those components, detail, working principle, everything you can read. So if you are going to describe about the this has been incorporated, classic way of describing this is take the flow meter at the center of your description. The component which is incorporated before the component which is incorporated at the level of flow meter, and the component which is incorporated beyond the flow meter. So you describe the safety features in that term. So you start saying that, the examiner knows that you know where what it is. Maybe the question will be skipped, or you may be asked to describe. At least tell me what are the safety features at the level of flow meter, or tell me the safety features which is incorporated before the flow meter, safety features which is incorporated after the flow meter. So just to name quickly brush through what are the things before the flow meter. Now to start from the York assembly itself, you have pin index system, you have for the pipeline you have Dss system, then from the wall mount thing you have NIST system, non-interchangeable connection. So all know what is NIST, what is Dss, what is PIS, that is pin index system, that all of you know. So that is the first level of safety. So what that does, which category it belongs, it prevents a wrong agent or wrong gas to be connected. So wrong, this thing cannot be connected. So that is that level. Then you have pressure regulator in that safety device for regulating the pressure, but leave that. That is not a classic thing. Then if you have a master slave regulator, that itself is a safety device. It is known as oxygen fail-safe device. So oxygen fail-safe device are different from anti-hypoxic devices like hypoxic guard. We will you should know the difference between the oxygen fail-safe device and hypoxic guard. So oxygen fail-safe device, in principle, what if there is no oxygen supply to the machine, or oxygen supply is below one particular pressure, commonly used pressure is 25 psi. If oxygen is below that pressure, it shuts up the machine. It doesn't allow any flow happening through the machine. That is why it is called oxygen fail-safe mechanism, oxygen fail-safe devices. So various types are there. The master slave is the most common example. You have various other things. I am not discussing. That is one. But what is the hypoxic guard? Hypoxic guard or anti-hypoxic mechanism. Guard is a specific term, and that can be asked in that way, or a anti-hypoxic mechanism. That mechanism, a mechanism which prevents any point of time the concentration of oxygen below one particular percentage. The commonest percentage, though we know the atmosphere is 21%, but the setting in devices are 25%. So anytime any flow happening through the machine, this device will make sure that the flow, the composition should at least have 25% oxygen. That is why it is called hypoxic guard or anti-hypoxic mechanism. You have various systems in that. Link 25 system. You have electronic when you have electronic mixture, electronic flow meter, you have electronic hypoxic guard. That is very sophisticated hypoxic guard. But the common one is you have proper system, and you have a link 25 system. You have various systems you can read. But at least you should know this is the hypoxic guard. What is the role of hypoxic guard? It prevents a gas mixture of anything less than 25% of FiO2 or oxygen. So that is at the level so that hypoxic guard can be mostly incorporated at the level of flow meter. So what are the other safety feature in the flow meter? You have touch coded knobs, oxygen touch code and nitrous oxide touch code are different, color coded there. then even having the oxygen in the downstream of the manifold is also considered as a safety feature. Then other things are there which you should know that what are the safety feature in that particular machine at the level of flow meter. Then you have beyond the flow meter, as we have already discussed, that the vaporizer should be agent specific, and the safety features in the vaporizer so that the wrong agent cannot be put into that. So one of the most commonest thing which is asked at the level of vaporizer in terms of safety is called select a tech mechanism. See, actually, that is a term used in Dss machine because the vaporizer there is known as tech series vaporizer. Select a tech means at a time you can select only one tech vaporizer. If you have that component incorporated into your component, one, your machine should have the back bar or the vaporizer manifold in such a measurement that the vaporizer, when you put two or more than two vaporizer in series, at a time, one vaporizer only can be opened. So select a tech mechanism is to open one particular vaporizer at a time. Multiple vaporizer cannot be opened. If that mechanism is not there, then if you have oxygen and isoflurane and sevoflurane vaporizer, or halogen and sevoflurane vaporizer, accidentally you can open two, then you have a big problem with that. So modern machine or whatever machine you are using right now are using either selected tech mechanism or some other mechanism. If it's a dragger machine, they have their own mechanism by which it prevents the opening of the second vaporizer if it is connected to your machine. So this you should know. What is a selected tech mechanism? What is the purpose of this mechanism? And why it is there, where it is there. So that is at the level of vaporizer. Then at the level of your the outflow, that already we have discussed, that is the machine outlet check valve. That is a pressure checking this thing. Then you have back pressure check valve there. Then there are host of safety and improvement features in your vaporizer itself, where it will that we talk about the pressure effect and pumping effect, how those things have been changed to incorporate those things. So that is a theoretical this thing. If you are being asked extensively about vaporizer, maybe sometime asked, but there are some safety features in that line also. Now, I think we have come up to, then you have the next level of safety, the commonest safety feature at the common gas outlet. Always you should have, this is going to be a mandatory feature for all the anesthesia machines. You should have an oxygen sensor, where that is the ultimate checking for your anti-hypoxic mechanism. You should always have an oxygen sensor at the level, and it should also be incorporated as a part of your alarm, where if particular percentage of oxygen is not going out from your common gas outlet. So whatever safety features have been incorporated in the machine can sometimes malfunction, can sometimes fail, can sometimes be override. But if you have a oxygen sensor at the level of common gas outlet, that is the ultimate mechanism for preventing or alarming you for a hypoxic mixture. So if something is what one technique or one mechanism you should have in your machine to prevent or alert you from delivering hypoxic mixture, the answer should be an oxygen sensor. That is a foolproof mechanism. So that is at the level of film. Now, after doing all this, last thing can be asked, again, that is a very important thing, but I am not going in detail of that. That is called pre-use check. So in this, you have two types of pre-use check. This is generally we follow the pre-use check, which has been described by ASA. So when there were pure pneumatic machine with this master and slave kind of mechanism, so there was one particular way of doing it. And so that is why they were called as step. Step one, you should do a tuck to the pipeline, then you should see, like that it is described. You switch on you remove the oxygen, see nitrous oxide, you connect the nitrous oxide, and all this. I'm not going into detail of that. But what I want to point out here is those were described in terms of steps. You should do step one before step two. But after 2008, and the ASA has changed because the machine has evolved. Various type of machines are there, and so there it is being described as in terms of items. So if you go to any standard textbook, you go to Miller or anywhere you go, you will see something mentioned as the I'll just check if I have that slide. If I have that slide, in the meantime, I'll show you that slide. There it is mentioned in terms of items. So you are supposed to check all the items. There are 15 items mentioned in that list. Item 1, item 2, item 3, item 4, like that it is mentioned. And who should check at what point of time? There are certain items which should be checked at the beginning of the day. There are certain items which should be checked in terms of in between the cases. Whenever you are inducing a new case, you should be able to check that. So the difference between the older pre-use check and the newer pre-use check is this newer one is item wise, and it can be customized based on your machine and your institute protocol. But one most important thing can be asked in a modern anesthesia workstation. There is something called self-test. So all these things are these items, whatever I have told, it is beyond self-test. So if you have a anesthesia workstation where the self-test is there, you have to first do a self-test. Then item-wise, you check all the items are completed or not. So I think we are in time and we have completed in 1 hour. So if anything else can be is requested or questions are asked, we can go ahead that with those things.
Hello. Thank you so much, Tripathi ji. It was, I mean, can you hear? Hello.
I am able to hear.
Yeah. Okay. I think in 1 hour, whatever could be covered, it is very difficult to cover everything in 1 hour. I'm pretty sure. But Dr. Tripathi tried to cover most commonly asked questions. There are some few questions which are very typical, specific to the examiners. It is very difficult to predict. But these are the must-know questions, I think, which Dr. Tripathi covered it. And this is how it should be answered. There are some theory part which we cannot discuss, in the Zoom video, which needs to be read from the textbook. Those things probably all the students should read. If anybody has any doubts, they can raise their hand or they can type. That can also be done. From ISA Puducherry, we are very thankful to Tripathi sir for his 1 hour without taking a break. Continuously he spoke. I know it's impossible to do unless you have depth of knowledge about the machine. So we are very thankful to you, Tripathi sir.